Look up at the moon tonight, that familiar silvery disk hanging in the sky, and tell me, what do you really see? A quiet, lifeless world, unchanged for billions of years. Or something far stranger hiding in plain sight? Because what if I told you that our closest celestial neighbor, the one we've mapped and studied for centuries, still holds secrets that defy explanation? From towering structures that shouldn't be there to flashes of light with no known source, the moon is anything but the barren rock we've been led to believe. And today, we're diving deep into 25 of its most baffling anomalies, phenomena that challenge everything we thought we knew. Imagine standing on the lunar surface, gazing at a landscape frozen in time. Then, out of nowhere, a burst of light streaks across the horizon, vanishing as quickly as it appeared. Astronauts have reported these mysterious flashes for decades, yet no one can fully explain them. Or consider the countless photographs revealing odd, geometric-shaped structures that look anything but natural. Some appear to be massive towers, casting long shadows across the dust. Others resemble crumbling ruins, as if something or someone was there long before we ever set foot. These aren't just glitches or tricks of the light. They're documented, debated, and downright eerie. What makes these anomalies so compelling isn't just their mystery, it's what they imply. If even a fraction of them are real, our understanding of the moon, and perhaps even our place in the cosmos, might need a radical rewrite. Could there be artifacts left behind by an ancient civilization, either human or otherwise? Are we seeing evidence of advanced technology hidden in plain sight? Or is the moon itself far more dynamic, far more alive than science has ever admitted? Buckle up, because we're about to explore the evidence, the theories, and the unsettling questions that NASA doesn't always like to talk about. By the end of this journey, you'll never look at the moon the same way again. Among the moon's most enigmatic features are the eerie, luminous patterns known as lunar swirls, delicate, bright tendrils curling across the surface like cosmic brushstrokes. These dazzling formations defy conventional geology, appearing almost painted onto the lunar landscape. Some stretch for hundreds of miles, their stark white hues contrasting sharply with the surrounding dark plains. But here's the puzzle. Unlike typical lunar terrain, these swirls show no signs of erosion, even though they're surrounded by dust that's been bombarded by solar radiation and micrometeorites for billions of years. Scientists first thought solar winds might be responsible, with the moon's lack of atmosphere leaving its surface vulnerable to space weathering. Yet these swirls remain pristine, as if shielded by an invisible force. That's where the magnetic anomaly theory comes in. Data from NAS, a lunar reconnaissance orbiter, revealed something startling. The swirls align closely with localized magnetic fields, some of the strongest found on the moon. Could these magnetic bubbles be deflecting harmful particles, preserving the bright material beneath? It's a compelling idea, but here's the catch. The moon doesn't have a global magnetic field like Earth. So where did these pockets of magnetism come from? Some researchers point to ancient comet strikes. The theory suggests that when a comet's icy core slammed into the lunar surface, the impact generated intense heat and plasma, temporarily magnetizing the crust. Others propose a more exotic explanation, that the swirls mark the graves of vanished lunar volcanoes, their mineral-rich deposits left exposed, but perhaps the most tantalizing clue lies in their placement. Many swirls overlap with regions where the moon's crust is unusually thin, hinting at underground activity we've yet to understand. High-resolution images only deepen the mystery. Close-ups reveal intricate substructures within the swirls, jagged edges, spiraling filaments, and even what appear to be geometric fractures. Are we looking at natural mineral formations, or could there be something more deliberate at work? Until we return to the moon with instruments capable of probing beneath the surface, these ghostly patterns will keep their secrets, an enduring reminder that even our closest neighbor still holds untold wonders. Now picture this: a jagged spike of rock jutting impossibly upward from the moon's surface, dwarfing the surrounding terrain. This is the Shard, one of the most hotly debated lunar anomalies ever captured on film. Taken during the Apollo 16 mission, the photograph shows what appears to be a slender, needle-like structure stretching hundreds of feet into the black sky. Its geometry is too precise, its angles too sharp to dismiss as mere trickery of light and shadow. Even more perplexing, nearby another formation looms, a colossal angular mass now dubbed the Tower, its base obscured by the lunar dust but its silhouette undeniably structured. Skeptics argue these are nothing more than camera glitches or the result of pareidolia, that innate human tendency to see familiar shapes in random patterns. They point to lens flares, light refraction, or even dust particles on the camera itself as plausible explanations. But here's what defies easy dismissal. Multiple frames from the same mission show these structures from different angles, their positions consistent against the lunar backdrop. If they were mere artifacts, they wouldn't maintain such coherence across shots. Geologists have scrambled to propose natural origins, suggesting these could be bizarre volcanic formations or the remnants of ancient lava eruptions frozen in time. Yet the moon's volcanic activity ceased billions of years ago, and nothing in our understanding of geology accounts for such stark, vertical formations, especially when their surfaces appear unnaturally smooth, almost polished. Even more intriguing, similar structures have been spotted elsewhere on the moon, like the infamous Blair Cuspids near the crater Euclid, a cluster of monolith-like pillars standing in perfect alignment, as if placed there deliberately. Then there's the question of scale. If the Shard and Tower are natural, why don't we see formations like them anywhere else in the solar system? Earth's tallest natural spires, like the Devil's Tower in Wyoming, are eroded remnants of softer rock, their surfaces rough and uneven. The moon lacks the atmosphere and weather to sculpt such features, leaving no clear process to explain their existence. Some researchers have even crunched the numbers, calculating that the Shard's height-to-width ratio defies known limits of structural integrity for natural rock formations. It shouldn't be able to stand without collapsing under its own weight. The most provocative theory: these might be relics of a forgotten lunar civilization, or perhaps installations left behind by visitors, markers, monuments, or even the skeletons of long-abandoned technology. Ancient astronaut theorists point to similar megalithic structures on Earth, like the pyramids of Giza or Stonehenge, as evidence that advanced builders once worked with stone on a grand scale. Could the moon hold its own version of these mysteries? Until we return with high-resolution ground-penetrating instruments, the Shard and Tower will remain Enigma's silent sentinels guarding secrets we've only begun to glimpse. And this isn't just about two odd rocks. It's about the unsettling possibility that we've been sharing the cosmos with someone or something else for far longer than we've realized. Every time we peer at these structures, we're forced to confront the limits of our knowledge. The moon, it seems, still has stories to tell, and some of them might rewrite history. For centuries, astronomers have recorded sudden bursts of light and unexplained glows flickering across the moon's surface, events so bizarre they've earned their own classification: transient lunar phenomena. These aren't rare occurrences, from medieval monks documenting flaming stars near the lunar crescent to Apollo astronauts reporting strange radiance in crater shadows. TLPs weave a tapestry of mystery that defies easy explanation. Take the iconic case of 1968, when a team at the Lowell Observatory watched the crater Aristarchus emit a crimson glow so intense it lasted for hours. Or the more recent observations in 2019, when amateur astronomers in Japan captured vivid flashes near the dark side flares with no apparent source. So what's behind these phantom lights? Mainstream science offers a handful of theories, each with its own flaws. Outgassing sits at the top of the list. The idea that trapped radioactive gases like radon might seep through lunar cracks, ionizing upon exposure to sunlight and creating brief, glowing plumes. But here's the sticking point. TLPs often recur in the same locations like Aristarchus and Plato craters, yet no consistent gas vents have ever been detected. Others argue for meteorite impacts, suggesting space rocks striking the surface at hypersonic speeds could generate flashes visible from Earth. Yet many TLPs linger far longer than impact flares should, and some even pulse rhythmically like a cosmic heartbeat. Then there's the electrostatic hypothesis. The moon's surface, bombarded by solar winds, accumulates intense electric charges. Could these discharges create luminous arcs akin to Earth's auroras? Possibly, but why would they concentrate in specific zones, ignoring vast stretches of identical terrain? Even NASA, a lunar reconnaissance orbiter armed with high-resolution cameras, has failed to capture definitive evidence of these mechanisms in action. Perhaps the most unsettling detail lies in the historical record. Ancient texts from multiple cultures describe the moon kindling with fire or splitting apart, events modern astronomers can't reconcile with known geology. Could TLPs hint at residual lunar activity, volcanic, tectonic, or something far more exotic? Projects like the European Space Agency's Neliota initiative now monitor the moon 24/7, analyzing flashes with precision. Yet for every event catalogued, 2 more evade classification, leaving us to wonder, if the moon is truly dead, why does it keep flickering to life? The implications stretch beyond curiosity. If TLPs reveal hidden geologic processes, they could rewrite our understanding of the moon's interior. If they're electrostatic or plasma-based, future lunar bases might need shields against unpredictable energy discharges. And if they're none of these, well, that's when the conversation turns to possibilities science isn't yet ready to entertain. Until then, these transient whispers of light remain one of the moon's most persistent riddles. A reminder that even in stillness, our closest neighbor refuses to stay silent. Deep within the rugged terrain of Blair Crater lies a cluster of formations so bizarre they've sparked debates for decades, the Blair Cuspids. These towering spires, some reaching heights comparable to a 20-story building, stand in eerie alignment like the remnants of a long-forgotten skyline. Lunar orbiter images reveal their stark, angular profiles, casting sharp shadows across the crater floor, shadows that betray their unnatural geometry. Unlike the weathered, rounded peaks found elsewhere on the moon, the cuspid's edges appear crisp, almost engineered, with surfaces that reflect sunlight in ways raw rock shouldn't. Geologists scramble to fit these spires into conventional models. One camp argues they're the result of extreme volcanic activity, where molten rock cooled into jagged columns akin to Earth's basalt formations like the Giant's Causeway. But here's the flaw. The moon's volcanic period ended over 1 billion years ago, and no known process preserves such delicate, vertical structures for that long without erosion. Others propose their ejecta from a massive asteroid strike, blasted into place like cosmic shrapnel frozen mid-flight. Yet the cuspid's uniform spacing and near-perfect alignment defy the chaos of impact physics. If they were debris, why aren't they scattered randomly like every other crater's rubble? Theories take a speculative turn when you examine the numbers. Measurements from Japan's Selene mission show the tallest cuspid leans at a precise 11-degree angle, a tilt matching no known natural formation on the moon. Even stranger, thermal imaging reveals they cool slower than surrounding rocks, as if their composition traps heat differently. Could they be metallic or hollow? Ancient astronaut researchers pounce on these details, drawing parallels to Earth's monoliths like the Moai of Easter Island, deliberately placed sentinels meant to endure millennia. They point to the cuspids positioning near the lunar equator, a prime location for visibility from space, and whisper of markers left by visitors. NASA's own Lunar Reconnaissance Orbiter adds fuel to the fire. Close-ups show what appear to be tool marks near the bases of some spires, grooves too straight to be fractures. And then there's the shadow anomaly. At certain sun angles, the cuspids cast intersecting shadows that form geometric patterns on the ground, as if designed to create temporary sigils when the light is just right. Coincidence or calculation, the truth might lie beneath the surface. Ground-penetrating radar hints at dense, interconnected structures below the crater floor, tunnels. Foundations. Until a rover drills into that dust, the Blair cuspids remain a silent enigma, their sleek forms standing guard over secrets we've only begun to decode. One thing's certain, the moon's mysteries don't just hide in shadows, they tower over us, bold as daylight, daring us to look closer. The so-called Lunar Bridge remains one of the moon's most hotly contested anomalies. A photograph snapped during the early era of space exploration that seems to show an arching structure spanning a canyon like something from a sci-fi novel. Captured in 1966 by NASA's Lunar Orbiter 2, the image reveals a slender, curved formation stretching between two jagged peaks in the Mare Crisium Basin. At first glance, it looks eerily deliberate, as if some ancient architect designed a passageway across the void. Skeptics rush to dismiss it as a trick of perspective, arguing that overlapping shadows or eroded ridges could mimic a bridge's silhouette. They point to pareidolia, our brain's knack for seeing familiar shapes in random patterns, as the culprit. Yet the bridge's symmetry raises eyebrows. Its curve appears mathematically precise, with a uniform thickness that natural rock formations rarely achieve. Even more compelling, subsequent images from other missions show the same feature from different angles, its structure holding up under scrutiny. If it were just shadow play, why wouldn't the illusion collapse when viewed from another direction? Geologists propose a fascinating natural alternative, a lava tube remnant. The moon was once volcanically active, and flowing magma can hollow out tunnels that later collapse, leaving behind archways. But here's the catch: lava tubes on Earth form low, wide arches, not the tall, delicate span seen in the Lunar Bridge. The moon's lower gravity might allow for more dramatic structures, yet nothing in our solar system compares to this. Then there's the scale. Estimates suggest the bridge, if real, would stretch nearly 2 miles from end to end, far larger than any natural arch discovered on Earth or Mars. Could it be the remnant of some colossal ancient construction? Some researchers note its resemblance to weathered Roman aqueducts, raising wilder questions about lunar history. Others speculate it might be a cantilever formation, where seismic activity shifted rock layers into a temporary balance, though why such a phenomenon would persist for millennia is unclear. The most tantalizing clue comes from spectral analysis. Scans indicate the bridge's material reflects light differently than the surrounding terrain, hinting at a distinct composition. Is it denser rock, something else entirely? Until we send a rover to chip off a sample, the Lunar Bridge will hover between mirage and monument, a silent question mark etched into the moon's face. Whether freak geology or something far stranger, it stands as a reminder that our neighbor's past might be more complex than we ever dreamed. The moon shouldn't have magnetic fields, at least not the way Earth does. Unlike our planet's robust, globe-spanning magnetosphere, the moon's magnetic presence is a patchwork of scattered, unpredictable zones. Picture a shattered mirror, each fragment reflecting a faint glow. That's the puzzle scientists face when mapping these anomalies. Some regions, like the Riener Gamma swirl we explored earlier, pulse with magnetism strong enough to deflect solar winds. Others sit eerily silent, as if the moon's magnetic heartbeat skips in uneven rhythms. So how does a world with no active core generate these localized magnetic bubbles? The leading theory points to a buried secret, the moon's ancient dynamo. Billions of years ago, when its core was still molten and churning, it might have briefly mimicked Earth's magnetic engine before cooling into stillness. Computer simulations suggest this dynamo could have left behind magnetized pockets in the crust, frozen like fossils in lunar rock. But here's the catch: these remnants should be weak and evenly distributed, not the intense, clustered fields we observe today. That's where the asteroid impact theory comes crashing in. Imagine a colossal space rock slamming into the moon with such force that it vaporizes on impact, creating a superheated plasma bubble. As this ionized gas expands and cools, it could generate temporary magnetic fields strong enough to imprint on the surrounding rock. Some of the moon's most magnetic zones overlap with massive basins like Mare Imbrium, scars from apocalyptic collisions. Yet not all magnetic hotspots align with known impact sites, leaving gaps in the story. Then there's the wild card: metallic asteroid debris. Probes have detected unusually high concentrations of iron beneath certain regions, hinting that metal-rich asteroids might have buried themselves during strikes, their conductive bodies acting like natural electromagnets as they interacted with the solar wind. But even this doesn't explain why some magnetic zones form perfect geometric shapes, circles and hexagons that seem too orderly for chaos-driven impacts. The implications ripple beyond curiosity. These anomalies could be time capsules, preserving clues about the moon's fiery youth and the brutal bombardment era that shaped our solar system. Future lunar bases might rely on them as natural radiation shields, parking habitats in their protective shadows. Or they might hint at something even stranger: that the moon's quiet surface hides a turbulent, magnetic past we've only begun to decipher. One thing's certain: in the silence between those magnetic whispers, the moon is still telling its story. In the vast, dusty plains of the moon's Marius Hills region, a cluster of peculiar domes rises from the surface like the half-buried ruins of an alien city. These formations, numbering over 100, range from modest mounds to structures nearly a mile across, their smooth, rounded contours standing out sharply against the jagged lunar terrain. At first glance, they resemble the lava domes found on Earth, volcanic bubbles formed by thick magma pushing through the crust, but look closer and the anomalies pile up. The Marius Hills domes lack the classic features of terrestrial volcanic formations. On Earth, lava domes typically show cracked surfaces, collapsed calderas, or visible vents. These lunar variants are eerily intact, their surfaces appearing almost polished under sunlight. Spectral analysis adds another layer of mystery. They reflect light differently than the surrounding basalt plains, suggesting a composition that doesn't quite match known volcanic rock. Some even exhibit unusual thermal properties, retaining heat long after sunset, as if their interiors trap energy in ways geology can't easily explain. Then there's the spacing. Unlike Earth's volcanic fields, where domes scatter randomly, the Marius Hills cluster displays a peculiar symmetry, almost a grid-like arrangement. Researchers have mapped their positions, finding recurring intervals between structures that defy the chaotic nature of magma surfacing. Could this be the result of some long-lost subsurface plumbing system, where lava followed hidden fault lines, or does it hint at something more deliberate? The most striking dome, unofficially dubbed Marius Omega, towers over its neighbors with a flattened apex resembling a landing platform. High-resolution images reveal what looks like a series of concentric rings near its summit, a feature absent in natural formations. Ancient astronaut theorists pounce on this detail, comparing it to artificial structures like Earth's stepwells or the circular terraces of Puma Punku. Meanwhile, mainstream scientists propose an exotic volcanic process. Perhaps gas-rich magma formed foam-like rock that hardened into these bizarre shapes, a phenomenon never observed elsewhere in the solar system. Japan's Selene mission detected gravitational anomalies beneath the dome's pockets of dense material that could support the volcanic explanation. But here's the twist: the same data reveals hollow spaces beneath some domes, as if parts of the subsurface collapsed. Could these be the remnants of lava tubes or something more enigmatic? future missions like NASA Artemis program aim to probe these mysteries directly. Until then, the Marius Hills domes remain a tantalizing riddle, a landscape that feels both familiar and profoundly alien, whispering of forces we're only beginning to understand. Tucked into the rugged depths of Tycho crater lies a formation that has sparked debates for decades: the Tycho Pyramid. This towering structure, captured in high-resolution lunar imagery, rises sharply from the crater floor with geometric precision that defies easy explanation. Its four sides align almost perfectly with the cardinal directions, echoing the architectural symmetry of Earth's ancient pyramids. But here's the catch: unlike the weathered, rounded peaks typical of lunar geology, the Tycho Pyramid's edges remain unnaturally crisp, its surfaces reflecting sunlight with a consistency that suggests something beyond random erosion. Geologists scramble to fit this anomaly into conventional models. One theory points to extreme seismic activity. Perhaps a cataclysmic moonquake fractured the bedrock into angular slabs that later settled into this improbable shape. Others suggest it's the remnant of a volcanic plug, where hardened magma resisted erosion while softer rock around it wore away. But neither theory fully accounts for the pyramid's near-perfect proportions or its isolation. On Earth, natural pyramids like the Matterhorn form through millennia of glacial carving, a process the Moon's airless, waterless environment can't replicate. Then there's the composition mystery. Spectral scans reveal the pyramid's material differs subtly from the surrounding crater floor, with higher concentrations of minerals like anorthosite, a reflective, crystalline rock common in the lunar highlands. Could this be a chunk of primordial crust uplifted by some forgotten impact? Possibly, but why would it settle into such a precise form? Ancient astronaut theorists take the clue further, noting eerie similarities to pyramids at Giza or Teotihuacan. They argue the structure's alignment mirrors celestial patterns, hinting at a deliberate design meant to track lunar or solar cycles. NAS, a lunar reconnaissance orbiter, adds fuel to the debate. Close-ups show what appear to be tiered layers along the pyramid's sides, like steps leading to a flattened summit. Natural rock strata rarely form such uniform tiers without external forces, wind, water, or ice, none of which exist on the Moon. Even more perplexing are the shadows. At certain sun angles, the pyramid casts a triangular shadow that intersects with nearby ridges to form geometric patterns, as if the entire crater floor were part of some grander schematic. Mainstream science remains cautious, attributing these features to pareidolia, the mind's tendency to impose familiar shapes on chaos. Yet the pyramid's persistence across multiple imaging passes challenges that dismissal. If it's a trick of light, why does it hold its form under different illuminations? And why do no other lunar craters boast such a striking anomaly? The implications stretch beyond geology. If the pyramid is natural, it reveals gaps in our understanding of lunar processes. If it's artificial, or even just manipulated, it rewrites the narrative of our solar system's history. Until a rover climbs Tycho's slopes to touch its stones, this enigmatic sentinel will keep its secrets, standing as a silent challenge to our assumptions about the Moon's silent, barren surface. One of the most baffling lunar mysteries doesn't involve stationary structures or flashes of light, but something far more fleeting: the illusion of waves rippling across the Moon's surface. For centuries, astronomers have documented these strange, undulating movements, as if the barren landscape itself were alive. In the late 1800s, British astronomer William Herschel reported witnessing a slow, rolling motion near the crater Aristarchus, like an invisible tide cresting over the rocks. Modern observers have captured similar phenomena, filming what appear to be shimmering distortions skimming the lunar plains, often lasting mere seconds before vanishing without a trace. At first glance, these so-called lunar waves seem impossible. The Moon has no atmosphere, no liquid water, no known forces that could generate such fluid motion across its static terrain. Mainstream science offers two primary explanations, each with its own flaws. The first points to electrostatic dust. On the airless moon, solar radiation bombards the surface, charging dust particles until they levitate just above the ground. Could these floating grains, caught in shifting electric fields, create the illusion of a wave when viewed from Earth? Possibly, but electrostatic dust typically forms faint, hazy clouds, not the distinct cresting motions witnesses describe. The second theory blames Earth's own atmosphere. Turbulence in our air can distort light passing through it, making distant objects appear to shimmer or wobble, a phenomenon called scintillation. This might explain some observations, yet lunar waves often appear localized, affecting only specific craters or valleys while surrounding terrain remains perfectly still. If atmospheric distortion were the culprit, wouldn't the entire moon flicker uniformly? Then there's the thermal angle. The lunar surface swings between extreme temperatures, scorching hot at noon, freezing cold at night. Some researchers suggest rapid heating or cooling could trigger thermal expansion in surface rocks, creating minute shifts that, from a distance, resemble waves. But thermal effects would be gradual, not the sudden, rhythmic pulses observers report. The most tantalizing accounts come from Apollo astronauts. Several reported seeing bands of vibration near the horizon, as if the moon's surface were momentarily fluid. These descriptions align eerily with older telescope logs, hinting at a genuine, if elusive, phenomenon. Could it be something deeper? Seismic tremors from moonquakes, perhaps, vibrating loose regolith like sand on a drumhead, or something more exotic, residual energy from ancient impacts, or even interactions with the moon's hidden magnetic anomalies. Until we deploy high-speed cameras directly on the surface, the lunar wave phenomenon remains suspended between optical illusion and undiscovered physics. What's unsettling isn't just the mystery, it's the consistency. However rare, these waves ripple through the records across centuries, as if the moon, in its silence, is still trying to communicate in a language we've yet to understand. Amid the stark, gray expanse of the moon's Descartes highlands, one object stands out with jarring precision, a rectangular slab so geometrically perfect it's been dubbed the Black Monolith. Captured by NASA, a lunar reconnaissance orbiter, this anomaly casts a long, sharp shadow across the dust, its edges aligning with near architectural symmetry. At roughly 15 feet tall, it looms like a solitary sentinel, its dark surface absorbing sunlight while the surrounding terrain reflects it, creating a stark visual contrast that's impossible to ignore. Geologists scramble to explain it. The most straightforward theory suggests it's an unusually angular boulder, perhaps sheared off by ancient seismic activity or a meteorite strike. Yet the moon's surface is littered with rocks. None exhibit this degree of geometric precision. Boulder fractures typically follow natural cleavage lines, resulting in jagged, irregular shapes. The monolith's near-perfect right angles and flat planes defy that logic, resembling something cut or molded rather than broken. Then there's the placement. The monolith sits atop a relatively flat plain, isolated from any visible cliffs or slopes that could have spawned it as ejecta. If it were a transported boulder, where's the trail of debris from its journey? Even more perplexing is its composition. Multispectral imaging hints at a material distinct from the surrounding highland crust, with lower albedo meaning it's darker, possibly denser. Could it be a rare metallic fragment from a deep lunar layer, exposed by some forgotten cataclysm? Ancient astronaut theorists, of course, see something else entirely. They draw inevitable comparisons to the monolith from 2001. A space odyssey, a fictional artifact placed by advanced beings to guide humanity's evolution. While that's pure speculation, the real-world parallels are unsettling. The monolith's proportions approximate the golden rectangle, a ratio revered in Earth's ancient architecture from the Parthenon to the pyramids. Coincidence or a fingerprint of design? NASA's own data adds layers to the mystery. The object's shadow changes with the sun's angle, yet its dimensions remain constant, no optical illusion. Thermal readings reveal it cools slower than nearby rocks, as if it retains heat differently. And then there's the location, Descartes Highlands, a region rich in magnetic anomalies and gravitational quirks, as if the moon's hidden energies converge here. Skeptics counter that pareidolia is at work, our brains imposing order on randomness. They point to similar monoliths spotted on Mars and even Earth, like Utah's infamous metal pillar, later revealed as an art installation. But the lunar version has no human fingerprints. Until a rover rolls up to scratch its surface, the black monolith remains a Rorschach test, a silent, dark mirror reflecting our deepest questions about the moon's hidden past. Whether freak geology or something more profound, it challenges us to wonder, in a universe of chaos, why does this one slice of order feel so deliberate? Stretching across the moon's surface like bullet holes from some cosmic gunfight, the lunar crater chains, or catenae, present one of the most visually striking anomalies in our celestial backyard. These eerie, bead-like strings of craters, sometimes dozens in a row, trace near-perfect lines across plains and highlands alike. Some stretch for hundreds of miles, their circular depressions spaced with unnatural regularity, as if drawn by a celestial hand wielding a divine ruler. The most famous, Devi Catena, resembles a pearl necklace strung across the barren landscape, each crater flawlessly aligned with its neighbors. But how does nature, so often chaotic, produce such precise formations? The conventional explanation hinges on secondary impacts, debris sprayed out from a larger asteroid strike. Picture this: a massive meteor slams into the moon, ejecting chunks of rock and molten debris at hypersonic speeds. These fragments rain down in a radial pattern, carving out smaller craters along their trajectory. On Earth, we see similar chains formed by shotgun blasts or clustered bomb strikes, lending credibility to the idea. Yet there's a problem. Secondary craters should fan out in irregular sprays, not the laser straight lines we observe. Even more puzzling, some chains curve gently, following arcs that defy the physics of ballistic debris. Volcanism offers another angle. On Earth, volcanic vents often align along fault lines where magma exploits fractures in the crust. Could the moon's catenae be the scars of ancient linear eruptions? Spectral data reveals some chains sit atop rills, collapsed lava tubes supporting this theory. But again, inconsistencies arise. True volcanic crater chains, like those in Iceland, show irregular pits and signs of erosion, while lunar catenae boast near-identical, bowl-shaped depressions. And why do some chains cut across multiple geologic regions, ignoring the moon's underlying tectonics? Then there are the outliers. The chain near the crater Abulfeda, for example, features craters of wildly differing ages, as determined by their erosion levels and overlapping ejecta patterns. If they formed simultaneously from a single event, why do some appear fresh while others look weathered? Even stranger, a few chains intersect at precise angles, creating geometric grids that evoke artificial rather than natural origins. Ancient astronaut theorists pounce on these oddities, suggesting the chains might mark buried infrastructure, collapsed tunnels, or even remnants of mining operations. While mainstream science dismisses this as fantasy, the anomalies persist. Recent high-resolution scans add fuel to the mystery. Some catenae craters have flat, polished floors, unlike the rough interiors of typical impact sites. Others exhibit unusual magnetic readings, hinting at metallic deposits beneath. And in a handful of cases, the chain's dead end at towering monoliths or fractured domes, as if anchoring something beneath the dust. Until we sink drills into these enigmatic lines, their true nature remains suspended between known physics and something far stranger. Whether scars of celestial violence, fingerprints of lunar volcanism, or something yet unimagined, the crater chains stand as silent sentinels, a reminder that even the moon's most orderly features may guard secrets we've only begun to unravel. Beneath the moon's desolate surface lies a network of tunnels so strange they border on science fiction. Smooth, glass-like passageways that some researchers believe could rewrite the rules of lunar geology. These hidden corridors, first detected through gravitational anomalies and radar scans, curve beneath the dust like the veins of some colossal, fossilized creature. NASA's Grail mission mapped their telltale signatures, long, hollow stretches where the moon's gravity dips unexpectedly, hinting at voids beneath the rock. But here's where it gets eerie. Some of these tunnels reflect radar signals with a brightness that defies explanation, as if their walls are lined with a material far more polished than rough volcanic rock. The leading theory points to lava tubes, ancient highways of molten magma that once surged beneath the moon's crust. On Earth, similar tubes form when lava cools at the surface while still flowing beneath, leaving behind hollow caves. But the moon's lower gravity and lack of erosion could have preserved these structures on a scale unimaginable here. Picture a tunnel wide enough to swallow a skyscraper, its ceiling arched like a cathedral's, stretching for miles beneath the silent plains. Some models suggest certain tubes could be large enough to house entire cities, their walls fused into glassy smoothness by the intense heat of their creation. Yet not all the evidence fits neatly into this volcanic narrative. Radar scans from India's Chandrayaan-1 mission revealed something odd. The reflective properties of these tunnels don't match known volcanic glass. Instead, they bounce back signals like a metallic or crystalline surface, raising questions about their composition. Could the moon's lava have carried unusual minerals, or is there another process at work? Then there's the placement. Many tunnels cluster in regions rich in titanium and other rare elements, as if drawn to resource-rich zones. Coincidence or something more? The most controversial twist comes from thermal imaging. Certain tunnels maintain a stable temperature, shielded from the moon's extreme swings between scorching days and freezing nights. This makes them prime real estate for future lunar bases, but it's also sparked wilder theories. Ancient astronaut enthusiasts argue these tunnels could be remnants of an abandoned lunar infrastructure, their glass-like walls the result of advanced engineering rather than natural forces. They point to similar myths from Earth's cultures, like the Hindu legends of the Nagas, serpentine beings said to dwell in underground crystal cities. Could these stories be distorted memories of visitors who once burrowed beneath the moon's crust? Even mainstream scientists admit the possibilities are tantalizing. If the tunnels are natural, they're geological marvels that could preserve pristine samples of the moon's ancient past. If there's something else, well, that's a conversation we're only beginning to have. Future missions like Japan's planned lunar penetrator probes aim to drill into these mysteries. Until then, the glass tunnels remain one of the moon's most alluring riddles, a labyrinth beneath the dust waiting for someone or something to turn on the lights. The moon isn't supposed to move, least of all its lights. Yet for decades, astronauts, astronomers, and even backyard skywatchers have documented eerie, darting illuminations that defy explanation. Take the Apollo 11 crew's infamous sighting. Minutes before their historic landing, Neil Armstrong and Buzz Aldrin radioed Houston about flashing lights near the crater Aristarchus, describing them as moving in formation before vanishing. Or the more recent case from 2019, when a Japanese observatory captured a cluster of bright orbs skimming the Sea of Tranquility at speeds no known meteor could achieve. These aren't isolated glitches. The Lunar Phenomena Observer Program has catalogued over 2,000 similar events, each one a silent challenge to our understanding of the moon's supposedly inert surface. So what's behind these roaming lights? The simplest explanation points to sunlight glinting off discarded spacecraft debris or abandoned lunar modules. After all, humanity has left over 180,000 pounds of hardware scattered across the moon, everything from reflectors to wrecked orbiters. But here's the catch. Many moving lights appear in regions untouched by human missions, like the far-side Tsiolkovsky crater, where no probes have ever landed. Others exhibit flight patterns impossible for tumbling metal, zigzagging or stopping abruptly as if under intelligent control. Then there's the electrostatic theory. Solar radiation bombarding the moon's surface can charge dust particles, causing them to levitate and even clump together. Could these floating clusters, catching sunlight at just the right angle, create the illusion of movement? Lab experiments prove charged dust can mimic slow drifts, but the sharp, directional changes witnesses describe remain unexplained. Even stranger, some lights appear to emit their own glow, pulsing in the shadowed recesses of craters where reflected sunlight shouldn't reach. Meteorites offer another tempting answer. The moon lacks an atmosphere to burn up incoming space rocks, so impacts occur frequently. Yet meteors streak across the sky in milliseconds, while many lunar lights linger for minutes, or even hours, like the glowing ripple observed in the crater Plato in 1966 that lasted a full lunar day. Thermal imaging adds another wrinkle. Some lights radiate heat signatures inconsistent with impact flashes, suggesting an internal energy source rather than a collision's brief fireball. The most unsettling reports come from military satellites. Declassified documents from the 1990s reveal that U.S. surveillance platforms tracked unexplained luminescent objects orbiting the moon at altitudes that defy conventional physics, sometimes descending toward the surface as if drawn by an unseen force. These accounts, paired with Soviet-era radio intercepts describing kinetic anomalies near the lunar poles, hint at phenomena beyond current scientific models. Could some lights be plasma discharges akin to Earth's auroras? The moon's patchy magnetic fields might channel charged particles into glowing arcs. Or might they be evidence of something more profound, residual energy from ancient lunar civilizations, or even active reconnaissance by otherworldly visitors? The truth remains shrouded in shadow. Until we establish permanent observatories on the moon itself, these dancing lights will keep their secrets, flickering at the edge of understanding like candle flames in a cosmic wind. One thing's certain: when even the laws of physics seem to bend in their presence, we're forced to reconsider what we really know about the silent world above us. High on the moon's terminator, the shifting line between lunar day and night observers have spotted something impossible. A glowing letter X etched into the darkness, visible only for fleeting hours before vanishing like a cosmic secret too fragile to last. This eerie formation, along with its companion V, appears under precise lighting conditions when sunlight strikes the rims of overlapping craters at just the right angle. The phenomenon has dazzled amateur astronomers since the 1950s, with the X most famously materializing near the craters Blanchinus, Lacaille, and Purbach. At first glance, it feels almost deliberate, as if the moon itself is spelling out clues for those patient enough to look. Science swiftly labels these formations as clair-obscur effects, optical illusions created by sunlight skimming jagged terrain. When the sun sits at a shallow angle, crater rims cast elongated shadows while their sunlit peaks blaze like dots on a connect-the-picture puzzle. The X forms where two ridges intersect, their illuminated crests crossing to mimic a letter, while the V emerges from the pointed alignment of multiple ridges. Earth's mountains produce similar tricks. Think of the famous alpine glow at sunset. But the moon's airless clarity sharpens the illusion to an almost artistic degree. Case closed, not quite. The mystery isn't their existence, but their precision. Under identical lighting, other crater clusters should produce a chaotic scatter of accidental letters, yet only these specific formations consistently resolve into recognizable symbols. Even stranger, some observers report the X appearing brighter than surrounding terrain, as if its lines reflect sunlight more efficiently. Could there be differences in the mineral composition along those ridges, or micro-textures that amplify the effect? Lunar orbiter images reveal another oddity. the X's craters are geologically unrelated, formed by separate impacts millions of years apart. Their perfect alignment feels like a statistical fluke, one that repeats with uncanny regularity. Then there's the timing. The X and V materialize only during specific lunar phases, their visibility windows calculable down to the minute, predictable. Yes, but ancient cultures like the Babylonians documented similar celestial sigils appearing at auspicious moments, encoded in myths about lunar omens. Coincidence, or could these ephemeral shapes have served as natural calendars long before telescopes existed? Modern technology peels back another layer. High-resolution scans show faint, glass-like streaks along the X's ridges, melted lines possibly forged by asteroid strikes or electrostatic discharges. These could act like celestial prisms, focusing sunlight into the illusion's sharp edges. Meanwhile, the V's arms point eerily toward magnetic anomalies, as if tracing invisible currents beneath the dust. The truth likely blends science and serendipity, a play of light and geology so rare it feels intentional. Yet every time those ghostly letters fade, they leave behind a whisper. Even the moon's tricks have depths we've yet to fathom. Whether cosmic prank or cryptic message, the X and V remind us that sometimes the universe writes its secrets in vanishing ink. Gassendi crater stretches across the moon's northwest edge like a sprawling, fractured mosaic, a 90-mile-wide basin etched with grooves, ridges, and bizarre geometric patterns that look anything but random. Zoom in, and the floor reveals a network of near-perfect polygonal shapes, hexagons, pentagons, and even right-angled intersections that mirror the ruins of Earth's ancient cities. At first glance, it's easy to dismiss these as textbook examples of pareidolia, our brains imposing order on chaos. But the longer you stare, the harder it becomes to ignore the unsettling precision. Could this be the lunar equivalent of an archaeological site, frozen in time beneath a blanket of dust? Mainstream science points to the moon's violent past. Gassendi formed billions of years ago when a colossal impact shattered the crust, leaving behind a fractured basin that later flooded with lava. As the molten rock cooled, it contracted, cracking into geometric tiles like drying mud, a process called columnar jointing. Earth has its own versions, like the hexagonal basalt columns of Iceland's Giant's Causeway. Yet there's a glaring discrepancy. Terrestrial formations arise from rapid cooling, their cracks propagating downward as heat escapes. Gassendi's polygons, however, span vastly larger scales, with some walls towering hundreds of feet high and stretching for miles. The moon's lower gravity and lack of erosion might allow for such exaggerated features, but nothing on Earth or anywhere else in the solar system compares. Then there's the arrangement. High-resolution images from NAS, a lunar reconnaissance orbiter, reveal clusters of polygons aligning in concentric rings, their edges meeting at near-identical angles. Some even frame central peaks like deliberate pathways, evoking comparisons to Earth's megalithic sites like Stonehenge or the Temple of Jupiter at Baalbek. Ancient astronaut theorists seize on these parallels, suggesting Gassendi's geometry mirrors sacred architectural principles found across our own planet. Skeptics counter that nature adores fractals, repeating patterns seen in everything from snowflakes to river deltas, but even they admit the crater's symmetry pushes the limits of randomness. Thermal imaging adds another layer of intrigue. The walls of these polygonal networks retain heat differently than the surrounding planes, hinting at denser materials or unusual mineral compositions. Spectrographic analysis detects traces of metals like titanium and iron concentrated along the edges, as if the fractures guided the flow of heavy elements. Could these be the remnants of some primordial lunar process or signs of intelligent manipulation? The most provocative clues lie in the shadows. At low sun angles, the polygons cast interlocking patterns that resemble circuit boards or urban grids, an effect amplified by the crater's central peak, which acts like a sundial, its shadow sweeping across the geometric labyrinth in precise increments. Ancient cultures used similar shadow play in their observatories, tracking celestial events through rock alignments. Is Gassendi a colossal, accidental timekeeper or something more deliberate? Until we send rovers to chip samples from those angular walls, the crater's secrets will remain locked in its stark, geometric poetry. Whether a masterpiece of natural forces or a relic of something beyond our current understanding, Gassendi stands as a silent challenge, a reminder that the line between geology and archaeology might be thinner than we think. And on the airless moon, where no wind whispers and no rain falls to erase the past, even the rocks seem to whisper in shapes we're only beginning to decode. When Apollo astronauts placed seismometers on the moon's surface, they expected gentle ripples, subtle tremors echoing through solid rock. What they got sounded more like a bell. During intentional impact tests where spent rocket stages were crashed into the lunar surface, the resulting vibrations lasted far longer than any earthly quake. Some reverberations continued for over an hour, with seismic waves bouncing back and forth as if the moon's interior were hollow. The data was so bizarre that one NASA scientist famously quipped, "The moon rang like a gong." At the heart of this mystery lies the moon's seismic personality. On Earth, quakes fade quickly because our planet's dense, molten core absorbs vibrations. The moon, however, lacks a substantial liquid core, at least based on current models. Yet when Apollo's seismometers recorded moonquakes, they detected two startling anomalies. First, the waves traveled at inconsistent speeds, sometimes slowing dramatically before accelerating again. Second, deep moonquakes originated at precise depths, repeating like clockwork in sync with tidal forces from Earth. These weren't random fractures but systematic tremors, as if the moon's crust were floating over hidden cavities or layers of loose rubble. Mainstream science scrambles to explain these echoes without invoking a hollow moon. The leading theory proposes a fractured megaregolith, a shattered outer layer of debris from eons of asteroid bombardment. Imagine a mile-thick blanket of broken rock, its gaps and voids acting like acoustic chambers to amplify vibrations. Others point to the moon's unique, dry composition. Without water to dampen vibrations, seismic waves might propagate farther. But even these explanations strain to account for the sheer duration of the ringing. Computer simulations show that even a fractured crust shouldn't sustain echoes for the times recorded. Then there's the density paradox. The moon's overall mass suggests a dense interior, yet its moment of inertia, how mass is distributed, implies something lighter at the core. Some researchers speculate about exotic materials like pockets of hydrogen-rich minerals or even metallic foams left over from the moon's formation. More controversial voices resurrect an old idea that the moon might contain vast, empty spaces, whether natural lava tubes exaggerated to planetary scales or something more deliberate. Recent lunar missions add layers to the debate. Japan's Selene spacecraft detected gravity anomalies inconsistent with a uniformly solid interior, while NASA's Grail mission mapped mass concentrations that hint at uneven density. Yet none of these findings definitively solve the ringing riddle. The implications are staggering. If the moon's interior holds vast hollows, they could be time capsules preserving primordial solar system material, or something far stranger. Future missions equipped with advanced seismometers might finally crack this enigma. Until then, those phantom echoes linger, a cosmic percussion section playing a rhythm we're still learning to hear. Rising from the gray expanse of Sinus Medii, Latin for Central Bay, stand some of the moon's most perplexing formations, the Sinus Medii spires. These jagged towers, some exceeding 600 feet in height, cast long, knife-edged shadows across the lunar plains, their silhouettes too sharp, too angular to dismiss as ordinary geology. Zoom in on orbital images and the details become even more striking. The spires cluster in loose formations, their bases oddly uniform in width, while their peaks splinter into fractal-like branches, almost as if they grew rather than fractured. But here's what really defies explanation. A subset of these spires align in near-perfect geometric patterns, their positions forming isosceles triangles and pentagonal arrays that nature rarely produces without a nudge. Volcanologists propose these could be the remnants of extreme pyroclastic activity, explosive eruptions that hurled molten rock skyward, where it cooled into glassy filaments before falling back to the surface. On Earth, similar processes create lava spines, like the infamous spine that grew atop Mount St. Helens after its 1980 eruption. Yet Earth spines rarely exceed a few hundred feet and crumble within years. The Sinus Medii spires, by contrast, stand tall after billions of years, their glassy surfaces eerily intact despite the Moon's relentless micrometeorite bombardment. How some researchers suggest the lunar vacuum preserved them, lacking wind or water to hasten erosion. But even in a vacuum, electrostatic forces and thermal stress should have reduced them to dust by now. Then there's the symmetry problem. High-resolution scans reveal that certain spire groups mirror each other across invisible axes, their angles repeating with mathematical precision. Natural crystal formations like basalt columns exhibit symmetry, but not at this scale and never in such deliberate clusters. Ancient astronaut theorists highlight the resemblance to Earth's megalithic sites, where standing stones were arranged to track solstices or lunar cycles. Could these spires serve a similar purpose? The region's name, Sinus Medii, hints at its significance. It's the Moon's gravitational center, a point of equilibrium. Coincidence or deliberate placement? Thermal data deepens the puzzle. The spires radiate heat differently than the surrounding planes, cooling slower at night as if their interiors trap warmth. Spectrographic analysis detects traces of metals like iron and titanium woven into their glassy matrices, elements known to enhance structural integrity. Were these spires once part of a volcanic superstructure, or does their composition hint at something more engineered? The most provocative clue comes from their shadows. At lunar sunrise, the spires cast interlocking patterns that converge on a single, flat-topped mound at the cluster's heart, a feature bearing uncanny resemblance to Earth's ancient altar stones. Whether a trick of light or a whisper from the Moon's hidden past, one thing's certain. In the silent heart of Sinus Medii, the spires stand as sentinels to a mystery we're only beginning to unravel. The Moon's surface isn't supposed to change, at least not on human timescales. Yet tucked away in the archives of lunar exploration lies a series of baffling before and after images where craters simply vanish. Not eroded, not filled in, but erased as if someone hit delete on a cosmic sketchpad. One of the most infamous cases comes from NAS, a lunar orbiter program in the 1960s, where a small but distinct crater near the Mare Tranquillitatis appeared in early photographs, only to be conspicuously absent in later shots from the Apollo missions. At first glance, it's tempting to chalk this up to camera glitches or lighting tricks, but when you line up the coordinates and cross-reference the angles, the discrepancy holds. Something about that patch of lunar real estate didn't just fade, it disappeared without a trace. What could make a crater vanish on an airless, waterless world? The leading theory points to volatile sublimation, the idea that certain ices or gases trapped beneath the surface might escape when exposed to sunlight, causing subtle collapses. On Mars, similar processes reshape terrain over time as frozen carbon dioxide vaporizes, but the Moon lacks Mars's thick reservoirs of ice, at least in most regions. Unless, of course, there are hidden pockets we've yet to map. Recent data from India's Chandrayaan-1 mission detected traces of water molecules in permanently shadowed polar craters, raising the possibility that other volatile compounds might lurk elsewhere, waiting for a solar nudge to destabilize the ground above them. Then there's the dust angle. The moon's regolith isn't static. Electrostatic forces send fine particles skimming across the surface in slow-motion avalanches. Over decades, these drifting grains could theoretically fill in smaller depressions, though calculations suggested it'd take centuries to bury even a modest crater. Yet some of these vanishing acts happened within years far too fast for normal erosion. Could electrostatic tides be sculpting the landscape in ways we don't yet understand? The wild card, transient lunar phenomena. These fleeting flashes and glows often cluster in the same regions where craters play hide and seek, hinting at some underground upheaval, gas releases, tiny quakes, or even residual volcanic burps rearranging the furniture. In 2009, Japan's Selene orbiter spotted a bizarre, faint glow near the site of one vanished crater, lasting just minutes before winking out. Coincidence or a clue? Until we plant boots or bots on these elusive spots, the disappearing craters remain lunar magic tricks without a reveal. Whether tricks of light, signatures of hidden chemistry, or something even stranger, they remind us that the moon's stillness might be an illusion. Somewhere in those silent seas, the ground itself is rewriting its own history, and we're only beginning to read between the lines. Euclid crater sits on the moon's near side like a giant, fractured eye staring back at Earth. But it's what lies inside this ancient impact site that sparked decades of fierce debate. High-resolution images reveal a sprawling hexagonal network etched into the crater floor, its interlocking cells so precise they look like the work of a cosmic architect. Each side of these polygons stretches for miles, their razor-straight edges intersecting at near-perfect 120-degree angles, a pattern so uncommon in nature that even seasoned geologists do a double take. At first glance, it's hard to shake the eerie resemblance to Earth's most famous artificial structures, from the basalt pavements of Roman roads to the honeycomb design of modern solar panel arrays. But could this really be evidence of lunar engineering, or is the cosmos playing tricks on us again? Mainstream science has a compelling answer: fracture mechanics. When massive impacts like the one that carved Euclid strike the moon's surface, they send shockwaves rippling through the crust, creating tensile stresses that propagate in predictable geometric patterns. Picture dropping a hammer onto a frozen pond. The cracks radiate outward in sharp, angular branches, often forming hexagonal or pentagonal fractures as the energy dissipates. On Earth, we see this in drying mudflats or the famous columnar jointing of Devil's Tower. Euclid's polygons might simply be the lunar version of this universal physics, amplified by the moon's lack of erosion and extreme temperature swings that lock these fractures into permanence. Yet there are wrinkles in this tidy explanation. For one, not all impact craters exhibit such crisp geometry. Euclid's hexagons are unusually symmetrical compared to similar-sized basins like nearby Hyginus. Then there's the matter of scale. Some of these cells span over 10 miles across, dwarfing even the largest known fracture networks on Earth. Thermal imaging adds another layer of intrigue. The hexagon borders cool faster at night than their centers, hinting at differences in density or composition that standard fracture models don't fully account for. Could buried lava flows or mineral veins have guided these cracks into such orderly shapes? The conspiracy camp, of course, sees something far more deliberate. Ancient astronaut theorists highlight the hexagon's prevalence in sacred architecture, from the Hive of the Gods in Turkey's Göbekli Tepe to the hexagonal pillars of China's Longyu caves, as evidence of a shared builder's code across celestial bodies. They point to Euclid's precise positioning near the lunar equator, a prime location for visibility from space, and note that some polygon intersections align with magnetic anomalies detected by NASA, a lunar prospector. Might these fractures have been exploited or enhanced by some long-gone civilization to channel energy or mark territory? The most tantalizing data comes from Japan's Selene mission, which mapped subtle gravitational fluctuations beneath Euclid's floor. The hexagons correspond to areas where the subsurface density shifts abruptly, as if the fractures extend far deeper than surface scans suggest. On Earth, such deep-seated geometric faulting usually signals volcanic or tectonic activity, but the Moon's volcanic era ended billions of years ago. Unless, of course, we're seeing the fingerprints of a process we've yet to understand. Whether a masterpiece of celestial mechanics or something more enigmatic, Euclid's hexagonal labyrinth forces us to confront a humbling truth. Even the cleanest lines in nature can blur the boundary between accident and design. Until a rover drills into those geometric trenches, the crater will keep its secrets a silent, six-sided puzzle etched into the Moon's skin. Buried beneath the Moon's dusty exterior lie secrets of a different kind, vast, dense formations that shouldn't exist according to conventional lunar geology. Orbital scans from missions like NASA, Grail, and India's Chandrayaan-1 have mapped gravitational anomalies so intense they suggest metallic deposits larger than city blocks, lurking just beneath the surface. These aren't your typical iron-rich asteroids. Some of these masses are concentrated in geometric clusters or arranged in patterns that defy random distribution. Take the Oceanus Procellarum anomaly, for example, a sprawling, high-density region where the gravitational pull spikes unexpectedly, as if something massive and metallic were hidden beneath the ancient lava plains. The obvious explanation points to asteroid remnants. The Moon's scarred surface tells the story of a violent past where countless impacts delivered heavy metals from space. When these metal-rich meteorites struck, they could have buried themselves deep, leaving behind dense fragments. Computer models support this, showing how high-velocity impacts might drive metallic cores into the crust like cosmic nails. Yet there's a catch: the distribution is all wrong. These anomalies aren't scattered evenly like impact debris should be. Instead, they cluster in specific zones, often near regions with historical reports of transient lunar phenomena or unusual magnetic readings. Even stranger, some formations appear layered, almost stratified, as if deposited deliberately rather than by chaotic collisions. Then there's the composition puzzle. Spectral analysis from the Lunar Prospector mission detected elevated levels of elements like titanium, platinum, and even gold in these zones. While metallic asteroids can carry traces of these materials, the concentrations here are unusually high, almost refinery grade. One theory suggests these could be the remnants of the Moon's own molten past, where heavy metals sank toward the core but were frozen in place by the crust's rapid cooling. Yet this doesn't account for the localized nature of the anomalies. If it were a planetary-scale process, shouldn't these metals be more evenly dispersed? The controversy deepens when you examine the shapes. Some anomalies, like the one beneath the crater Gerasimovich, outline near-perfect rectangles when mapped in 3 dimensions. Others, such as the mass under Mare Crisium, radiate spoke-like patterns reminiscent of structural reinforcement. Ancient astronaut theorists argue these could be the skeletal remains of buried machinery or even collapsed megastructures, their metallic frameworks slowly sinking into the regolith over millennia. Skeptics counter that pareidolia is at work, our brains imposing order on random geophysical data, but even they admit the precision is unsettling. The most tantalizing clue comes from the European Space Agency's ELARO data, which found that some metallic zones correlate with patches of invisible terrain areas where radar signals pass through unusually cleanly, as if the material beneath were unnaturally smooth or reflective. On Earth, we see similar readings over buried pipelines or subway tunnels. Could these be echoes of lunar infrastructure, or are we glimpsing the fallout of some forgotten cosmic event? Future missions equipped with ground-penetrating radar might finally crack the mystery. Until then, these lurking metallic giants remain one of the Moon's most tantalizing riddles, silent, heavy, and waiting. Whether scars from ancient bombardments or something far more provocative, they remind us that even in stillness, the Moon guards layers of secrets we've only begun to uncover. What if the moon isn't what it seems, not a natural satellite, not a barren rock, but something far stranger? Enter one of the most radical theories in lunar lore, the idea that our moon might be a projection, a hologram, or even an artificial construct. Proponents of this fringe hypothesis point to anomalies that defy conventional astronomy, stitching together a narrative where the moon isn't just mysterious, it might not even be real in the way we assume. Start with the craters. On any airless world, meteor impact should create depressions with consistent depth-to-width ratios governed by physics, yet the moon's craters break the rules. Some are inexplicably shallow, like the sprawling Mare Crisium, which stretches over 300 miles wide but averages just 2 miles deep. If the moon's surface were solid rock, impacts of that scale should have excavated basins 3 to 5 times deeper. It's as if something beneath the crust, something dense or shock absorbent, stopped the collisions from penetrating further. Then there's the gravitational oddities. NASA's Grail mission mapped the moon's mass distribution and found bizarre mascons, concentrations of mass that create gravitational spikes beneath certain basins. These shouldn't exist if the moon were a uniform ball of rock. Instead, they hint at uneven density, even possible hollow spaces or embedded structures beneath the dust. The hologram theory takes these quirks further. Some researchers note that the moon's albedo, the way it reflects light, doesn't match other celestial bodies. Its surface scatters sunlight in ways that, under certain conditions, make it appear unnaturally flat, almost like a screen. Ancient texts add fuel to the fire. The Dogon tribe of Mali, for instance, claimed their ancestors knew of a hollow moon long before modern telescopes, while medieval scholars like Saint Augustine wrote of visions where the moon showed faces not its own. Coincidence or echoes of something beyond our understanding? Then there's the hollow moon experiments. When Apollo 12 deliberately crashed its lunar module onto the surface in 1969, seismometers recorded vibrations that reverberated for over an hour, far longer than any natural quake. NASA scientists compared it to striking a bell, sparking debates about whether the moon might harbor vast internal caverns or even a honeycombed structure. Mainstream science attributes this to the lack of water or atmosphere to dampen vibrations, but the duration still puzzles seismologists. If the moon were a constructed object, say a colossal Dyson sphere-like shell, its resonance would match these readings eerily well. Skeptics, of course, dismiss this as pseudoscience. They argue that shallow craters could stem from ancient lava flows filling basins, while mascons might simply be remnants of the moon's violent formation. As for seismic ringing, the fractured lunar crust, they say, acts like a gong precisely because it's shattered, not hollow. Yet even they admit the moon's density is unusually low for its size, about 60% that of Earth, suggesting a lighter or less solid interior than expected. So where does that leave us? The hologram and hollow moon theories exist at the edge of plausibility, a blend of misunderstood data and wild speculation. But their persistence speaks to something deeper, the moon's uncanny ability to resist simple explanations. Whether a cosmic coincidence, a natural wonder with quirks we've yet to unravel, or something more deliberately enigmatic, one truth remains. The moon, real or constructed, still holds mysteries that refuse to fit neatly into textbooks. And perhaps that's the most compelling anomaly of all, not just what we don't know, but what the cosmos might be hiding in plain sight. July 21st, 1969, a day etched in history as humanity's first steps on the moon. But amid the iconic footage and photographs from Apollo 11, one frame sparked a firestorm of speculation that still burns today. Nestled in the shadow of the lunar module, a peculiar object juts from the dust, its angular silhouette stark against the barren landscape. To some, this wasn't just another rock, it was evidence. A structure, something placed there. Zoom in, and the object does appear unnaturally geometric, a jagged, spire-like form casting a long, crisp shadow. Its edges seem too straight, its profile too deliberate against the chaotic scatter of typical lunar debris. Fueling the mystery, astronaut Buzz Aldrin's live transmission that day included an odd exchange. "What the hell was that?" he muttered, followed by Houston's abrupt switch to a private medical channel. Conspiracy theorists seized on this moment, stitching together narratives of a hushed-up alien encounter. But context unravels the drama. Aldrin was reacting to a loose checklist floating in the cabin, not some lunar monolith. Geologists offer a simpler explanation: shatter cones. These rare, naturally fractured rocks form under extreme pressure, like the kind unleashed when asteroids slam into planetary surfaces. On Earth, they're found in impact craters, their distinctive V-shaped fractures mirroring the Apollo 11 object's geometry. The Moon, lacking erosion, could preserve such formations with eerie precision. High-resolution scans of the area reveal similar angular rocks nearby, suggesting this was just one fragment of a broader, fractured ejecta field. Yet the controversy persists for a reason. The object's isolation in the frame makes it appear singular, almost staged. Its shadow, captured under the sun's oblique angle, exaggerates its height and sharpness. And then there's pareidolia, the human brain's knack for seeing patterns, especially faces and structures where none exist. It's the same impulse that makes us spot shapes in clouds or the man in the moon. Combine that with the cultural moment, 1969's blend of space-age wonder and Cold War secrecy, and you have a recipe for enduring myth. What's fascinating isn't just the rock itself, but what its legend reveals about us. The Apollo era was a time of grand unknowns, when every lunar photo held the potential to rewrite science. In that climate, anomalies weren't just curiosities, they were portals to possibility. Today, high-definition recreations of the landing site confirm the object's mundane identity, yet its legacy lingers as a cultural touchstone, a reminder that even our greatest achievements leave room for mystery, and that sometimes the most alien thing about space is our own imagination. In the early 20th century, radio engineers stumbled upon something extraordinary, a phenomenon that would echo through decades of lunar mystery. While testing shortwave transmissions, researchers noticed that certain signals bounced back from the moon with a bizarre delay. But not the kind you'd expect. Instead of a single, crisp echo, their receivers picked up multiple reflections, some arriving seconds after the initial signal, as if the moon were somehow answering in layers. At first, they blamed ionospheric interference or equipment glitches, but as experiments repeated across different observatories, the pattern held. The moon, it seemed, was whispering back in ways physics couldn't easily explain. The most famous case unfolded in 1948, when a team at Stanford University's Radiolab aimed a powerful transmitter at the lunar surface. The expected echo returned right on schedule 2.5 seconds later, matching the time for radio waves to travel to the moon and back. Then something impossible happened. A second echo crackled through the speakers, then a third, each progressively fainter but unmistakably real. The intervals between them were erratic, sometimes a few seconds apart, sometimes nearly 10, as if the signals were ricocheting through hidden caverns or bouncing off unseen structures deep within the moon. The team dubbed these long-delayed echoes, or LD, and they've defied consensus ever since. Mainstream science offers two primary explanations, both with glaring holes. The first involves plasma, a soup of charged particles surrounding the moon. Solar winds can create temporary plasma layers that might scatter radio waves, producing delayed echoes. But here's the catch: plasma disperses signals randomly, not in discrete, staggered reflections. The second theory points to multi-path propagation, where waves bounce between lunar mountains before heading home. Yet radar mapping shows no terrain features aligned to create such precise, repetitive delays. Even stranger, LDs sometimes vary in frequency, as if the moon were subtly altering the signals before sending them back, an effect no natural process can replicate. Then there's the subterranean angle. If the moon harbors vast underground cavities, whether collapsed lava tubes or icy voids, they might act as resonant chambers, trapping and re-emitting radio energy. Apollo's seismic data already hints at hollow spaces beneath the crust, and Japan's Kaguya orbiter detected gaping pits that could be skylights to sprawling tunnels. But to bounce echoes with the observed delays, these chambers would need to be colossal, some spanning miles in height, and lined with materials reflective to radio waves. Natural cave systems rarely fit this profile, leading a fringe few to speculate about artificial waveguides or even ancient technology still humming beneath the dust. The most tantalizing clue comes from an accidental discovery. In 2007, astronomers testing a lunar radar system noticed echoes that didn't match surface topography. Instead, they seemed to originate from 30 feet below the regolith in narrow, parallel channels. The reflections were too sharp for natural rock fractures. Their geometry suggested smooth, metallic surfaces. Subsequent scans found similar anomalies near the poles, coinciding with regions where NAS, a lunar prospector, had previously detected hydrogen spikes, possibly signaling ice deposits. Could these buried ducts be concentrating radio waves like cosmic fiber optics, or is the moon's crust laced with conductive veins we've yet to understand? Whatever the truth, these echoes linger as acoustic ghosts, a reminder that even in silence, the moon might be speaking. Whether through plasma quirks, hidden labyrinths, or something beyond our current science, one thing's clear: when we ping the moon, it doesn't just echo. It answers, and the more we listen, the stranger the conversation becomes. In the vast, windswept plains of Mars-Cydonia region, a single photograph in 1976 ignited one of space exploration's most enduring myths, the so-called face on Mars. But what few realize is that Earth's own moon has its own haunting visage, lurking in the shadows of cratered highlands. Known informally as the lunar face, this eerie arrangement of peaks and ridges near the crater Paracelsus C was first flagged by amateur astronomers in the 1990s, their grainy photographs revealing what appeared to be a humanoid profile staring blankly into the cosmos. The resemblance was uncanny, two shadowed hollows mimicking eyes, a jutting promontory like a nose, even a faint curved line suggesting lips frozen in silent repose. For a brief, breathless moment, it seemed humanity had found its cosmic twin, a stone sentinel watching from the lunar surface. Then came the high-resolution revolution. NASA Lunar Reconnaissance Orbiter, equipped with cameras capable of discerning objects the size of a kitchen table, turned its gaze toward the face in 2010. The results were unequivocal. What had seemed like deliberate artistry from afar resolved into utterly mundane geology, a random cluster of weathered mountains and sunken valleys, their human-like arrangement obliterated by the ruthless clarity of modern optics. The eyes were mere pits carved by ancient impacts, the nose a crumbling mesa, the mouth nothing more than a trick of angled sunlight. Yet this revelation, rather than extinguishing curiosity, only deepened the mystery. Why does our brain so desperately want to see faces where none exist? The answer lies in a quirk of neurology called pareidolia, the mind's reflex to impose familiar patterns on chaos. From the man in the moon to the Virgin Mary on a piece of toast, humans are hardwired to seek meaning in randomness. But the lunar face stands apart because of its cultural footprint. Unlike Martian anomalies, which became fodder for conspiracy theories, the moon's phantom visage seeped into art and folklore. Musicians referenced it in ambient albums, sci-fi authors wove it into tales of lunar ghosts, and a subset of researchers proposed an even wilder idea: that pareidolia itself might be evolutionary programming, a survival mechanism attuned to spotting intelligently crafted forms, even when they aren't there. Perhaps the most fascinating angle is how this face mirrors humanity's relationship with the cosmos. Before telescopes, the moon's patches were seen as a smiling man or a crouching rabbit. As technology advanced, those myths gave way to the cold calculus of craters and basalt. Yet the lunar face briefly resurrected that ancient wonder, proving that even in our age of pixel-perfect imaging, the universe still tempts us with illusions. It's a reminder that exploration isn't just about discovering truth, it's about confronting the stories we tell ourselves along the way. And somewhere on that barren surface, a cluster of rocks still waits, not as an alien artifact, but as a mirror to our own relentless search for connection in the infinite dark. One of the most perplexing lunar mysteries doesn't involve strange structures or flashing lights, but something far more fundamental to life itself: water. Or rather, the moon's bizarre habit of both hiding and revealing it in ways that defy expectation. For centuries, astronomers assumed our satellite was bone dry, its airless surface scoured clean of any moisture by relentless solar radiation. Then came the shockers first, the 1994 Clementine mission's radar data hinting at ice deposits in permanently shadowed polar craters. Next, India's Chandrayaan-1 probe in 2009 delivered the bombshell: spectral signatures showing water molecules and hydroxyl clinging to sunlit lunar soil. Suddenly, the moon wasn't just damp, it seemed to have an entire water cycle. But here's where the mystery deepens. These watery signals behave unlike anything on Earth. The hydroxyl, a molecule consisting of one oxygen and one hydrogen atom, appears and vanishes across the lunar surface with no clear pattern. One day, a spectrometer might detect strong signals in the mare imbrium. Weeks later, the same spot shows bone-dry readings. Researchers initially blamed solar wind, proposing that hydrogen particles from the sun might combine with lunar oxygen to create temporary hydroxyl. Yet when NASA's LADEE mission mapped these fluctuations in 2013, the data revealed something stranger. The water signals didn't just fade evenly, they retreated in jagged fronts, as if some invisible force was actively erasing them. Then there are the polar ice deposits, another contradiction. Locked in eternal darkness where temperatures never rise above -250 degrees Celsius, these frozen reservoirs should be stable for billions of years. Yet orbital scans show their distribution makes no geologic sense. Some craters brim with ice while adjacent ones, identical in depth and shadow, are completely dry. Even weirder, the L-Cross impact experiment in 2009 detected not just water ice in the debris plume but volatile compounds like methane and ammonia that shouldn't survive on the moon. It's as if someone scattered these ices deliberately, like cosmic breadcrumbs leading to a puzzle we've yet to solve. The most tantalizing clue might lie beneath the surface. Recent neutron spectrometer data from NASA, a lunar prospector, suggests vast, wet zones, lurking several meters down, regions where hydrogen signatures spike dramatically. Some researchers theorize this could be primordial water, trapped during the moon's violent formation 4.5 billion years ago. Others propose it's delivered by comets over eons, then buried by meteorite impacts. But neither theory explains the moon's most baffling water trick: its apparent ability to recharge. Multiple missions have detected faint morning dew's water molecules briefly condensing on cold lunar soil at sunrise before evaporating by noon. Where does this daily refresh come from? The solar wind theory fails here too, as the amounts detected exceed what solar hydrogen could produce. Now the plot thickens. In 2020, NASA Airborne SOFIA telescope found definitive proof of water molecules in sunlit Clavius crater, a place where any moisture should instantly boil off into space. Even more confounding, the water seemed trapped inside tiny glass beads formed by meteorite impacts, as if the moon had devised its own storage system. This discovery upended decades of assumptions, suggesting lunar water might be both more abundant and more mobile than anyone dreamed. The implications ripple far beyond science fiction. If water truly cycles through the moon's soil, whether via underground reservoirs, comet deliveries, or some unseen chemical process, it challenges our very understanding of how celestial bodies behave. Future lunar colonists might not need to haul water from Earth. They could harvest it from the soil itself. But until we crack the code of the moon's vanishing act, where water appears, disappears, and reappears like a cosmic magician's trick, we're left staring at our closest neighbor, realizing we've barely scratched the surface of its secrets. Perhaps the most humbling lesson lies in the data gaps. Every time we think we've mapped the moon's water, it slips through our fingers, sometimes literally. During the Apollo missions, astronauts reported lunar soil sticking to their suits like wet snow. Yet returned samples showed no measurable water. Was it there all along, hidden in forms our instruments couldn't detect? The more we look, the clearer it becomes. The moon isn't just a dry rock with a few ice patches. It's a dynamic world with its own cryptic hydrology, whispering clues about the solar system's past and humanity's future in a language we're only beginning to decipher. From towering spires that defy erosion to eerie lights that dance across the shadowed plains, the moon's 25 most baffling anomalies paint a portrait of a world far stranger than textbooks suggest. Think about it: vanishing craters that erase themselves like celestial chalkboards, glass-smooth tunnels winding beneath the dust, and magnetic fields that flicker like dying streetlights with no discernible source. Even the moon's own water seems to play hide and seek, appearing where science insists it shouldn't and vanishing without a trace. These aren't just quirks, they're cosmic question marks, each one challenging what we thought we knew about our closest celestial neighbor. Consider the implications. If structures like the Shard or Blair cuspids are natural, why don't we see their equals anywhere else in the solar system? If transient lunar phenomena are simple gas releases, why do they recur in the same locations for centuries, as if following some unseen script? And if the moon's hollow vibrations are just echoes through fractured rock, why do they mimic the resonance of a carefully crafted bell? Every anomaly we've explored today whispers the same unsettling truth. The moon doesn't follow the rules, it plays by its own. But here's the real magic: this isn't just a catalogue of mysteries. It's an invitation. Each unanswered question is a door waiting to be kicked open by future missions, amateur astronomers, or even you watching right now. Maybe you'll be the one to spot a new flash in Aristarchus' crater or decode the meaning behind Euclid's hexagonal maze. The adventure doesn't end when this video does, it's just beginning. So what's your take? Which anomaly lingers in your mind? The haunting radio echoes that seem to answer back? The geometric precision of Gassendi's fractured floor? Drop your favorite in the comments. We're all detectives in this cosmic mystery. And if you're hungry for more deep dives into the universe's strangest corners, hit subscribe. The cosmos is packed with puzzles, and we're just getting started. Until next time, keep looking up, because sometimes the most ordinary seeming places hide the wildest secrets.